Hello and welcome to Demola, and today's video we are covering alkenes. So we're going to do the properties, the reactions. We've already done stereoisomerism in a different video, so have a look at that. But no time to waste, let's talk about these compounds. Okay, so we're going to kick things off by talking about the properties of alkenes. So, general formula CnH2n, and they are unsaturated hydrocarbons, meaning they contain that carbon-to-carbon double bond, and they don't have the maximum number of hydrogens that they possibly could. Okay. So you can see here, this is an example of an alkene. 3 carbons, so we're going to use our prefix of prop, and then our suffix is ene, so propene. So prefix prop, suffix ene for the alkene group. Now, what you'll also see is that our C double bond C, or carbon double bond, contains pi and sigma bonds. So we've just decided to define those. A pi bond, important exam definitions by the way, I will add. Pi bonds are sideways overlaps of p orbitals above and below the sigma bond, whereas sigma bond is a head-on overlap between orbitals. Now, definitions important, so make sure you're getting those down. But specifically with a pi bond, you need to be able to draw it. This has always been good enough for me in exams. So you can see the p orbitals above and below. I've only drawn them in the y plane. You know there should be 3 planes, but I've only drawn in the y. So you can see these p orbitals above and below the carbon-to-carbon sigma bond. Yeah. Then the sideways overlap is that coil-looking thingy, and then you get these two here. And if you had to label it, I just put like a label here. That's a pi bond, and then you could like say this is like a p orbital. Okay. Now, in the carbon-to-carbon double bond, as you can see here, we need to look at the central carbon atom, and you can see here there are 1, 2, 3 bonding pairs. So don't worry about how many electrons are in each pair. I just need to know what are the bonding pairs. There's 3 of them. And carbon has 4 electrons in the outer shell. We're going to be using 1, 2, 3, and 4. So there's 3 bonding pairs, no lone pairs. And using our knowledge from module 2, bonding pairs repel each other equally. Hence, in an alkene, you're going to have a trigonal planar shape with a bond angle of 120 degrees. So make sure you're getting all of that down because it is important for you. Something about alkenes that make them distinct from alkanes other than the bonding is the fact that alkenes are very reactive. So, you know, in your alkane, you're just going to have the carbon-to-carbon sigma bond. In alkenes, you're going to have that pi bond, which is going to break first. It's weaker. So because the bond is weaker, there's not much energy needed to break it, and hence your alkenes really readily will undergo addition reactions. Okay. Now, what are the addition reactions? You need to know all of these for your A levels. So first one we're going to talk about is hydrogenation. So we'll focus on hydrogenation, addition of hydrogen. Yeah, and literally you have here, I've drawn it skeletal, but you have butene, remember 4 carbons, and then the suffix ene. So butene plus hydrogen, but very importantly, we are using a catalyst here. You need to remember reagents and conditions, please, please, please. But we're using a nickel catalyst, and we're going to form this compound, which is butane, the alkane. So alkene to alkane, hydrogenation with a nickel catalyst. Okay. The next one we need to talk about is halogenation, so addition of a halogen. And we can either do this with addition of a hydrogen halide or just the halogen itself. Now, so we're using butene again. If we do a hydrogen halide, we're going to add, first of all, let me just get my pen ready. We're going to add, first of all, the hydrogen and then also the chlorine. So that's why we're just going to get a chloroalkane. Yeah? So we've got a halogen alkane, essentially. A haloalkane, sorry. And then with this one, if we just do the halogen, then both of the atoms are going to put themselves on. So we're going to have a dihaloalkane. Hope that makes sense. Now, really important, and the reason why I picked bromine specifically is because this is actually a test for the alkene functional group, and it becomes a bit more important, I believe, in module 6. But if you react it with bromine water is specifically an orange brownish color. So if you add this, the bromine water reacts with the alkene group, and then you get this clear liquid. So clear, so brown orange to clear tells you, okay, there's an alkene group here. Now, hydration, addition of water. So what I shouldn't have said water, it's actually steam. Very important for your exam, steam. So butene plus steam with an acid catalyst present, bam. They normally use phosphoric acid, but it can be like sulfuric acid as well. But you will form an alcohol. So this is butanol, yeah? And very importantly, reagent condition, you're saying heat and acid catalyst. So those are the reactions that you need to know regarding alkenes. Okay, now it's really time to earn our money. So we're going to talk about electrophilic addition. And we've defined this before, but an electrophile is an electron pair acceptor. Remember, phile to be attracted to, so attracted to electrons, you're accepting electron pairs. Now, let's look at what's going on here. So we're going to break it down into steps, and the most we're going to just say things that are really important to remember for your exams. So we have our molecule, 1, 2, 3 carbons, alkene group, propene. Okay. Now, this is its carbon-to-carbon double bond, and you can imagine there are so many electrons in here. So many electrons in the carbon-to-carbon double bond. Now, if you look here, we talked about this term electronegativity before. And electronegativity dictates that this chloride, because it's more electronegative than hydrogen, it's going to attract, I should say chlorine, but it's going to attract the electrons in that covalent bond more strongly onto it. Okay. So if the electrons are in this bond more concentrated towards this side, then you can see why we're going to have delta minus near the chlorine, delta plus near the hydrogen. Now, this double bond, remember, there's a lot of electrons in it. It's got a really high electron density. It's going to be attracted to that hydrogen because it's delta positive. So those negative charges, remember, always negative charges moving are going to move towards the hydrogen. Now, very important points. Remember, in your mechanisms, you need to put the charges or polarities, and you also need to make sure your arrow is nice and curved with a double head because you're showing an electron pair moving. Okay. Now, let's see what happens next. So you form this thing called a carbon cation. More on that later. Cation because it's got the positive charge there. Now, you can see, if we just highlight it, so you can see what's changed, we've added on the hydrogen. So the hydrogen is now popped in here. Yeah? But that was the chlorine, right? Or now it's a chloride ion because it accepted the electron. Yeah? Heterolytic fission. Yeah? Accepted it, the pair of electrons. And hence why it's now a negative charge. Okay. So that negative charge is going to see, oh shoot, there's a nice juicy positively charged carbon there. I'm going to bind onto it. Yeah, so it binds onto that carbon in the carbon cation, and it's like, okay, now, bam, we formed our haloalkane or a chloroalkane. Okay, so this mechanism is so important, and you need to memorize it for your exams. However, there's also a key player here, Markovnikov's rule. I hope I've said that right, but Markovnikov's rule. And what that is that the hydrogen attaches to the carbon with the most hydrogens, or the more stable carbon cation. Okay, let's discuss, because that can get confusing, right? To simplify this down, because it's very unlikely for them to ask you to define Markovnikov's rule, you're just looking for the major product in your electrophilic addition is going to be the more stable carbon cation. So in a carbon cation, stability is determined by the amount of alkyl groups, or amount of carbons that the carbon cation is attached to. So if we say the carbon cation is this carbon with a positive charge, I'm looking how many carbons is that attached to. So here it's 1, so it's a primary carbon cation. That color doesn't work. Here it's 1, 2, secondary carbon cation. Here it's 1, 2, 3, so it's a tertiary carbon cation. And you just need to know in terms of stability, the tertiary carbon cations are the most stable, secondary is less stable than tertiary, and primary is the least stable. Okay, let's put this to work. So I've got 2 compounds here, yeah, at the bottom of my screen. The first one, let's investigate. This is the carbon cation, yeah? How many carbons is it attached to? Well, just the 1. Okay. What about this one? Our carbon cation is this one. How many carbons is it attached to? Well, 1, 2. So the first one here is a primary carbon cation, whilst this one is a secondary carbon cation. Okay. I've told you that secondary carbon cation is more stable, didn't I? So that means that our chloride group is more likely to say, I want to go and attach to this. Yeah? So about how bad the arrow looks, but it wants to attach to that. Okay. So then you get major and minor products. So your major product forms from the more stable carbon cation. This is what the reaction favors to produce. Whilst the minor product is the one that's produced less because it has a less stable carbon cation intermediate. I hope that makes sense in terms of Markovnikov's rule. It's quite high yield, not the definition, but just being able to apply it. Okay, and last but not least, we just need to talk about polymers. So in terms of polymers, we don't really need to spend too long on this, but you just need to be aware. We have addition polymerization. which is what happens with your alkenes. Now, when you get to year 13, we're going to go into condensation polymers, which is much more difficult. So let's just focus on what we've got here. So you've got an alkene. Here I've just drawn 2 carbons, ene, yeah? Literally, for this, you're just thinking, okay, break up that double bond. So we've broken the double bond, we've made it a single bond, and we're going to just like kind of almost move the double bond to the other sides. So you can see here, that's what's happened to our double bond. It's just extended on both sides, yeah? And literally, that's kind of it for polymers. You just need to be aware of this like notation, really. So this shows a repeat unit of your polymer. So if we were actually drawing the polymer, you would literally just have bam, 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 hydrogen, 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 and it will literally just repeat. So 1, 2, bam, 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 and then we'll keep going on and on and on, yeah? That's why we have the N here. So that's important as well. And then the brackets need to go through the bonds at the end of the repeat unit, yeah? So make sure that you are drawing that correctly in exam. Something that you will also need to do is to be able to spot what the repeating unit is, but again, shouldn't be too bad when it comes up. Now, a point that I think is more important for AQA rather than OCR, but just know high pressure, high temperature leads to more branching, low pressure, low temperature leads to a straight chain. Cool. And in terms of uses of polymers, I think the main ones to mention, combustion for energy and production of plastics are probably the best ones. PVC is kind of used for waterproofing as well. But those are all things you need to think about in terms of uses of polymers. I'm sure if you go through mark schemes, you'll see a bunch of uses listed there. And then one really, really important drawback of addition polymers is they are not biodegradable. So I'm sure you would have heard a lot about like shopping bags getting tossed in the sea and it's killing a lot of animals in the sea. So this is really important in terms of a consideration for us. Even as chemists, we need to think about things like this because we don't want to damage our environment. Okay, so we've got a couple of questions for you to try. The first one is about completing this flow chart. So unfortunately, very, very common question in A-level chemistry. So take your time with that. And then we need to talk about the catalyst for reaction 1 and then what you would observe in reaction 3. So these are things we've mentioned in the video that you need to bring to your remembrance. Then we have a question about polymers. So you can see there, addition, polymerization. You'll need to talk about saturated hydrocarbon bond angles and then also just ways that you can be sustainable. Very important things to consider. And these questions are kind of a bit likely to come up in your exam. So take your time, zoom in where you have to, and we'll get into it. Okay, so let's go through the answers. I'm first of all going to just go here. Now, I like to kind of draw a skeletal, so that's what I've done. You can see here, this is the molecule that we started with, hex-1-ene. I think I'll just put it to the opposite side of the answer, so we'll show that in a minute. But first of all, hydrogenation, very easy. Alkene to alkane, yes. So yeah, that was that. So you just draw a hexane in there. Now, major product. So what you're thinking here, okay, we're adding a halogen halide. I'm just thinking intermediate steps. One of them, we've got the carbon cation here, and the other one we have it here. So I need to think which ones are there. So this is attached to one carbon, meaning that it's a primary carbon cation, or the other one is attached to 2 carbons, so it's secondary, hence more stable, hence major product's going to form there. So that's why we've put the chlorine on carbon 2. And then finally with the bromine, we're just adding it across the double bond, so 1, 2. And you can see here, I'm just going to try and show it to you. I know it's a bit hard to kind of switch between, but you can see that's hexane, cool. You can see here, this is on carbon 2 if we're going from right to left. And then this one is on carbon 1 and 2 again, if we're going from right to left. So that's all I'm trying to say, yeah? Next one, like I said, reagents and conditions, very important. So hydrogenation, nickel catalyst. And then also this one, well, I had a problem with this actually because it says observe. So because it's observe, I guess you could say that you can argue you're seeing bromine be discolorized, but I would just go orange to colorless, really. I think that's a better way of saying it. And then finally, in the last one, we're thinking, okay, we have a polymer, right? Okay, but you can see all of them are single bonds. So it's fully saturated because of only single bonds. Also, you can see, okay, let's look at central carbon. We have 1, 2, 3, 4 bonds. So it's tetrahedral. There's no lone pairs because carbon has 4 in the outer shell. 109.5 degrees. Remember it from module 2. And then also, just in terms of the sustainability, again, I always just for these questions, I look at mark schemes and I kind of just go off that. So combustion for energy production, I think we said. And the one we didn't say was organic feedstock, which I think is a really good one to say in exams. Probably should be in my notes. But yeah, just make sure you're saying things like that when it comes to exam. Okay, and finally, we have to go through the ASR tips to round this up. So understanding the formation of pi bonds is really, really good. And being able to draw that is very important as well. So know about the sideways overlap above and below your carbon-to-carbon sigma bond. Now, properties of alkenes, properties of anything really is important. You'll see as we go through a bunch of different molecules in organic chemistry, but knowing its properties is quite good. And then also, just the reactions which alkenes undergo is very important. Being able to kind of list these 3, or maybe even 4 if you want to separate addition of a halogen halide, is very important. And then finally as well, the mechanism for electrophilic addition, please. It's the first one you need to know. There are 3 more throughout the course. You need to know these, because I don't think that as difficult marks as maybe some students make out. So make sure that you're doing these really, really well. Now, what's not good? Well, formation of the pi bond. I can't lie to you and say it's a common question, but it is one that comes up. I think it does come up. I've definitely had it before. So make sure that you can draw it, because if you just remember that, you don't need to know the whole details about like sp3 orbitals and stuff. If you do, fantastic, but you don't need that for the A level. Just be able to draw it. What else? Reaction mechanisms. I've seen too many students, guys, please. Arrows just need to be curly, like literally. Just make sure it's got a nice curve to it that the examiner can't ignore. Make sure it's double-headed like that, and then make sure that you're including charges when you need to. So you don't need to necessarily circle them. Charges need to be there. If it says show electrons, please show the electrons like that. And also, if you're showing electrons, make sure that your curly arrow is moving from the electrons. That's even a rubbish arrow. That's curly enough for the examiner. So please, please, please. And then also, for getting reagents and conditions, I'm going to like hammer this on throughout the whole of this module. Reagents and conditions can get you such simple marks, but I do appreciate there's a lot to learn. And then also, just uses and drawbacks of polymers. I think it's something that doesn't take too much time to memorize, but if you do memorize it, you can pick up some nice marks here and there. Okay, so that's the end of the video. A lot of talking, but hope it's been useful. Any questions at all, drop them in the comments below and I'll do my very best to answer them in a timely manner. If you liked the video, if you found it useful, please like and subscribe to the channel. We're doing really, really well at the moment, so thank you all for supporting. We've got our TikTok and our Instagram, both at demola. Links will be in the description below. But that's all from me for now. Thank you so much for listening, and I'll catch you in the next one. Bye for now.